Oh, hello, this is Professor Gilmet, and today the video is about confidence intervals for means. Alright, so we've been doing proportions and now we want to change to means. So today we want to learn how to create a confidence interval for means. The thought process and procedure is very similar to that of a proportion, and so if you need a reminder on how to do those, then check out the videos in the proportion series on my YouTube site. All right. So step one is we have to check the assumptions. Okay. So when we do a confidence interval, we don't actually know the value of the population mean. So we're actually trying to get a range of values that we can be confident the population mean is within. Okay. So to be able to calculate that range, we need to use the appropriate model. All right. So therefore, we must begin by checking with the assumptions. For means, with small samples, and we don't know the population standard deviation, the sigma, we use the student t-distribution. Oh, unless we know the value of the population standard deviation. I should really read these things before I do my videos. All right. So we begin checking the assumptions for means using the criteria for the student t-distribution. Now, it's very similar, okay? Independence. All right, does one member influence another? Random, was a good sampling technique used? Good sampling techniques are simple random sample, stratified sample, cluster sample, some sort of systematic sample. The 10% condition is the sample less than 10% of the population. For means, the sample sizes are usually very small. You'll see that today. And so this is not always bad, all right? So for means, this is almost always true, all right? And of course, I always use the easier 10 times n is going to be less than the population. But remember, this is almost always true, and so we don't need to worry about it too much, all right? Now, the sample size needs to be nearly normal. With small sample sizes, the central limit theorem may not be in full effect, as we saw with the cohabitation video that I did. And so when n is less than 15, the data must be nearly normal with little skewness and no outliers. Okay? Because the central limit theorem is not making that sampling distribution quite look like the student t yet. And so from 15 to 29, the data can be fairly normal with some moderate skewness. A little skewness is okay, but no outliers, all right? And then as n gets to be greater than 30, the data can exhibit some strong skewness, but if outliers are present, it is suggested you do the analysis with or without to determine the amount of influence. Now, for some books disciplines, the 29 will actually be 39, and the 30 will actually be 40. Okay, so just check. But these are the numbers that we're using. This is pretty consistent for a lot of things. All right. So now, what does this mean? What do these sample size conditions mean in practice? So, for example, let us look at two examples of sample size 6 in StatCrunch. All right, and remember, these must be normal with little skewness, because if the sample size is 6, it's less than 15. So the data's got to have little skewness and no outliers. And so I actually took some data for IQ, and if you use the WISC-4 intelligence test for children, the Wechsler Intelligence Scale for Children 4, you may get a sample that looks like this, all right? And the mean is 100, and the standard deviation for the test for everybody who's taking it is 10. And so I just generated some data here. Now, how do I tell if this data is nearly normal with little skewness? Well, basically what I do is I draw this beautiful histogram right here, and it looks like it's skewed to the right a little bit, but when you check out the median is 106 and the mean is 105, That's less than 1% difference. They're super close together, and so that is very little skewness. All right. Now I'd like to compare that to the IQ2 sample, which is also of size 6. But when I draw its histogram, now you can see I'm starting to get more skewed to the right. The median, the mean is 132, and the median is 121. So now there's actually 11-point difference, 11.5-point difference between them. That's pretty big. That's probably about 10%. And so this, I would say, is not showing a little bit of skewness. This is starting to show some moderate skewness. And so IQ2 data would fail, whereas IQ1 data would be okay. Now, for example, number 2, I'm going to look at 2 sample sizes of size 20 in StatCrunch. And so remember, these can show some skew but no outliers. All right? And so 20 is between 15 and 29. So some moderate skewness but no outliers. So again, I'm going to go to StatCrunch. And here it's the same WISC4. But now the sample size is 20. And so as I look at it, here's my IQ3. So you can see there's some skewness here, some moderate skewness. The mean is about 98 and the median is 93. So, there's about 5 points difference there. It's about 5%. You can see it's going over, but there's no outliers. And it's not showing real strong skewness. There's just some moderate skewness going on there. So this is going to be okay for sample size 20. However, when we look at IQ4 and I check out its histogram, the mean and the median are still about the same, but we definitely have this outlier over here at this data point of 151. And so this is not going to be acceptable because the rest of the data is fairly normal with this one outlier out here. So this is how you would be looking at this data, right? So that's what you would do with histograms, okay? So you can check it out in StatCrunch. Step number 2, we're going to do this calculations. I typically do these by hand. I've done a lot of these by hand so far. Today I just want to do it in StatCrunch. If you really want me to work it out on the TI calculator or by hand, because your professor is requiring that, leave a comment in the comment section and I will post a response video. But basically, whenever you're calculating the confidence interval for means, you have to identify the following. You have to know what the sample mean is, your X bar. You have to know what your sample standard deviation is, your S. Now remember, if you know sigma, you should be using z-scores in the normal model. But if we only know the sample standard deviation, then we're going to be using the student t, and then n, the sample size. And with these 3 things, right, we are able to calculate the confidence interval. And so note, the degree of freedom is 1 less than the sample size. Just wanted to throw that in there. But StatCrunch is just going to ask for the sample size and calculate the degree of freedom. Sometimes this information will be given to you in the problem, and sometimes you'll need to use data that's given. So I basically want to do both examples here. So let's say, for example, IQ1 sample, we saw that it met the criteria for using the student t distribution, and that data has the following values. So let's say they just said, hey, we've got a sample of size 6, and the mean is 105, and the standard deviation is 10. How would that work in StatCrunch, right? So I go to StatCrunch, and I'm looking at, I'm looking at the IQ1, right? And I calculated the mean and the standard deviation for that and the sample size. So what I'm going to do is I'm going to go to Stat, and I'm going to go down to my t-stats, because remember, we only have S, not sigma. And I'm going to go over to one sample because I only have one small sample here. And with this one, I'm going to use with summary because I actually have the summary of the mean, the standard deviation, and the sample size. And you'll see it's going to ask for mean, standard deviation, and sample size. So I'm going to go ahead and type in 105 as my mean score because the scores are always integer values for the WISC. The standard deviation that I'm going to put in is 10, again rounding to the nearest whole integer, and my sample size is 6. Now I'm going to change it from a hypothesis test to a confidence interval, and I'm just going to leave it as 95. I rarely store this in the data table. I don't think the formatting looks as pretty as leaving it as the pop-up box. So I'm going to click compute now, and my box comes up, and you'll see the sample mean is the same. The standard error is smaller, which it should be for a sample size of 6. There's my degrees of freedom, 5, one less than the 6 that I had. But here's the important part. Oh no. The lower limit is 94.5 and the upper limit is 115.5, basically. Might want to round that to the nearest whole integer, but I'm going to leave this up here for the Q1. So the mean of my population is going to be between 95 and 115. All right. So for IQ3, we also saw that it met the criteria for using the student T distribution. In this problem, they simply give you the data. So let's say they simply give you the data. So now I'm going to go back to StatCrunch, right? And again, the steps are stat, go down to your T-stats, go over to your one sample because I only have one sample, and then with data this time because now I just have all the data values. So I'm going to click on with data. Now I could have done this for IQ1 because the data is there, but I'm doing it for IQ3. So this is my larger sample size of 20. And again, I don't want a hypothesis test, I want a confidence interval, and let's go ahead and keep it as 95. And again, I don't actually like storing the data in the table, so I'm just going to now click compute. If I do that, you'll see that my mean is about 97. And if you look at the data here, it looks like it goes from about 83 is the smallest value up to about 131 is the largest value. So it seems reasonable that the sample mean is going to be about 98. The standard error is very small, but the reason the standard error is very small is because the degree of freedom is getting to be much larger, and so that sample size there, the sample size of 20, right, is going to make that standard deviation smaller. And so now we have values that go from 91 to 104. So I think this is a little bit smaller just based on the standard error, but it's centered slightly differently because here my mean is 97 and here my mean was 105. All right. So now we just need to interpret the output. What you'll see are variable, sample mean, standard error, degree of freedom, lower limit of the interval, and upper limit of the interval. Make sure that all these things are correct and look correct. And I did that, right? I looked at those. So when they give you the mean and the standard deviation, make sure the mean is the same and the standard error is smaller. A little bit smaller for very small samples, a lot smaller for larger samples. Check your degrees of freedom with your sample size. It should be one less. And when they give you the data, does it look right? I mean, does it appear like it's the same? Okay. And depending on how you check the nearly normal condition, is the mean correct? You know, we checked it in StatCrunch with our histograms, and so that actually gave us the mean, and so we should be able to identify those in both of these. All right, So that brings us to the conclusion. Now that we have our interval, we can write our conclusion. So like interval for proportions, we're saying that we have a certain confidence that the actual population value is within the interval. This has nothing to do with the samples or where all data will lie, right? Remember from our last video, it is simply a statement about where the population value can be found. Okay, and it could be at the edges and it could be in the middle. Therefore, our conclusion takes on the following form. We are 95% confident, that could be a different value, but we use 95% today, that the mean value of the trait for the population is between the lower limit and the upper limit that we saw in the output. Remember, it's going to give us sample mean, standard error, degree of freedom, lower limit, and upper limit. Okay? So in the context of the IQ problem we have been looking at, if we use the data from IQ3, we are 95% confident that the mean IQ for children, remember the WISC-4 is for children, is between 91 and 104. All right? So this means that the average for everyone, if we could test them all, right, should fall between 91 and 104. And this is actually true because the actual mean is 100. Okay, and so that makes everybody very happy. So this concludes this video. If you learned about how to do confidence intervals and what they mean, then that makes us very happy. And so until next time, keep doing stats and having fun, and that makes us happy. If you really like this video, please subscribe to the channel.